Good morning, students. Chapter 2 Electrostatic Potentials and Capacitors. Continue. We have completed all theories. Now it's time for illustrations and exercise questions. Okay. See, example 2.9. It is one question based on series and parallel connection of capacitors. How to identify series and parallel connection? How to apply rules to find charge and voltages? See carefully. Here you are given four identical capacitors C1, C2, C3 is equal to C4 10 microfarad. Four capacitors identical. They are connected with a battery having supply voltage 500. You are given figure, don't worry. Your question is find equivalent capacitance and question 2 charge on each capacitor. You are given this figure. See here carefully. This figure is given C1, C2, C3, C4 and it is battery having 500 volt supply. Now you have to identify series and parallel connection of capacitors. How to identify? See, it is battery. So let charge is flowing from this. Charge is flowing from this. Charge is flowing from this. Okay, charge is flowing from this. From this point, charge is divided in two parts. Charge is divided in two parts. Okay. Now if you observe this part, see. It is a single path. It is a single path, no branches. It is a single path. Means C1, C2 and C3, they are in same path. See, second plate of this capacitor is connected with this plate. Its second plate is connected with this plate. Okay. So from figure, first of all, you have to identify connection. From figure, it is very clear. It is C1, C2 and C3. They are connected end to end. They are connected end to end. Okay. So C1, C2 and C3, they are in series connection. So how to write? C1, C2, C3, they are in series connection. Let their equivalent capacitance is CS. Now for series connection, what is the equation? 1 upon CS is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Value 10 microfarad. So 1 upon CS is equal to 1 upon 10 plus 1 upon 10 plus 1 upon 10 is equal to 3 by 10. So C dash is equal to, it is 10 by 3 microfarad. Clear? So what is equivalence of these three capacitors? C dash is equal to 10 by 3 microfarad. Now how to draw figure? See, these three capacitors, they are replaced by this capacitor C dash. This will remain same. Okay, between these two ends, now we can draw only one capacitor, that is CS. Clear? So now from this second figure, now see, if you observe this second figure, two plates of this capacitor connected between these two ends, yes or no? Yes. Two ends of this capacitor, they are also connected between 2 points. Means two plates are connected with these 2 points. And this capacitor is also connected between two plates. These two capacitors are now in parallel connection with this battery. These two capacitors are now in parallel connection with battery. So how to write? C dash and C4, they are in parallel connection and their equivalent capacitance is C double dash. What is the equivalent capacitance of these two capacitors? C double dash. Okay, then how to find C double dash? C double dash is equal to C dash plus C4. 10 by 3 plus 10 is equal to 40 by 3 microfarad. Clear? And these two capacitors in parallel connection, they are replaced by only one capacitor, that is C double dash. Clear? So it is easy to find equivalent capacitance. Okay, initially this C1, C2 and C3, they are in series connection. Their equivalent, that is C dash, is in parallel connection with C4. Now they are in parallel connection, their equivalent is C double dash. Clear? So one question over, okay, how to find equivalent capacitance. Now we have to find what is charge on each capacitor. See, now you have to take reverse path. First of all, see this figure. C double dash, we know it's one. It is connected with battery having volt P is equal to 500 volt. So from C double dash, we know, 500 volt, we know. From these two data, we can find what is charge on capacitor. So let charge on capacitor C double dash is Q double dash is equal to C double dash into V. C double dash 40 by 3 into 500 is equal to 6666.67 microcoulomb. So what is charge on this C double dash? It is 6666.67 microcoulomb. Yes, it is not asked. It is not asked, but we will find this to identify or to verify our result. To verify our result. See, now as I said, you have to take reverse path. What is meaning of reverse path? First of all, you have to find what is charge on C double dash. Now ask the question, what is C double dash? What is C double dash? Take a reverse path. C double dash is equivalent capacitance for parallel connection of C dash and C4. For C dash and C4. And see, from this figure it is clear. C dash and C4, they are in parallel connection with this battery. C dash and C4, they are in parallel connection with this battery. Okay, and in parallel connection, what is same? In parallel connection, potential difference remains same. In parallel connection, potential difference remains same. As V is equal to 500 volt, potential difference across two ends of C4, 500 volt. Potential difference across two ends of C dash, 500 volt. So how to write? Now C dash is equivalent of parallel connection of C dash and C4. So potential difference across C double dash and C4, they are same. Potential difference across C dash and C4, they are same. V dash is equal to V4 is equal to 500. Clear from this figure? C dash, C4. They are connected with this battery. So potential difference between these two ends, potential difference between these two ends is equal to 500. So V dash is equal to V4 is equal to 500. Now see, you have one equation, that is C is equal to Q upon V. If two variables are given, you can easily find third one. See, now we know what is value of V dash. Yes or no? Yes. We also know what is value of C dash. 10 by 3. Then you can easily find what is charge on capacitor C dash. Charge on capacitor C dash, Q dash is equal to C dash into V. 10 by 3 into 500 is equal to 1666.67 microcoulomb. Clear? Okay. Similarly, what is charge on capacitor C4? Q4 is equal to C4 into V is equal to 10 into 500 is equal to 5000 microcoulomb. Clear? Okay. Now see, what is reason I have found this? See, here. We know that in series connection, charge is same. But in parallel connection, charge gets divided. See, what is total charge supplied by battery? It is 6666.67 microcoulomb. Now see here. From this battery, what is total charge supplied? 6666.67 microcoulomb. Then from this point it is divided into parts. In C4, Q4 5000, and in this branch it is 1666.67. So if you add these two charges, you will get this. And it is according to law of conservation of energy. 6666.67 charge is flowing, divided into two parts. Here it is 5000 and here it is 1666.67. Clear? Okay, so from this you can verify your answers. Now it is only charge on C4. Now we have to find what is charge on C1, C2 and C3. Again take a reverse path and ask the question, what is C dash? C dash is equivalent capacitance of series connection of C1, C2 and C3. And we know in series connection charge remains same. Then how to write? Charge on C dash is equal to charge on C1 is equal to charge on C2 is equal to charge on C3. Yes, we know in series connection charge on each and every capacitor is same. So charge on C dash is equal to charge on C1 is equal to charge on C2 is equal to charge on C3. So see, C dash is series connection of C1, C2 and C3. So charge on C1 is equal to charge on C2 is equal to charge on C3 is equal to charge on C dash. So Q1 is equal to Q2 is equal to Q3 is equal to Q dash. And what is value of Q dash? 1666.67. So it is your answer. Okay. So first of all you have to simplify circuit. Okay. And draw each and every circuit. Yes, draw each and every circuit. It is easy to understand. Clear? Pause your video and write down from board. Can you pause? Okay, now one more example on series and parallel connection. See what is question. Exercise 2.25. You are given this circuit. 4 capacitors are there. C1, C2, C3, C4 with a battery having voltage V is equal to 300 watt supply. Question is find equivalent capacitance and find charge and voltage across each capacitor. See again, first of all you have to identify which capacitors are in which connection. Okay, try and start from the easiest. Start from the easiest one. See, you are given this figure. So from this figure, first of all we can easily say, as it is only one path. As it is only one path, these 2 capacitors are in series connection. These 2 capacitors are in series connection. It is easily understand from this figure. Okay, that these 2 capacitors are in series connection because they are on same path. They are on same path. They are on same path. Okay, so C2 and C3 they are in series connection. Let their equivalent is C dash. So 1 upon C dash is equal to 1 upon C2 plus 1 upon C3. 1 upon C dash is equal to 1 upon 200 plus 1 upon 200. It is 2 upon 200. So C dash is equal to 100 picofarad. So equivalent of these 2 series connection capacitors is C dash and is equal to 100 picofarad. Now draw figure. Replace these 2 capacitors by only one capacitor, that is C dash, like this. See, C4 as it is, C1 as it is, battery as it is. These 2 capacitors are replaced by the C dash. Clear? Now how to check connection? See, it is positive terminal of battery and it is negative terminal of battery. If you make charge to flow, charge is flowing from this point, from this point charge gets divided in these 2 branches. From this point charge gets divided in these 2 branches, means 2 different paths. So these 2 capacitors are in parallel connection. Or how to say, see, these 2 plates connected these 2 points, these 2 points. Okay, this capacitor is also connected between these 2 points. Means C1 and C dash they are in parallel connection. C1 and C dash they are in parallel connection, and let their equivalent is C double dash. So C double dash is equal to C dash plus C1. C double dash is equal to 100% rate. C double dash is equal to 200 picofarad. Okay, so these 2 capacitors are in parallel connection and their equivalent is C double dash. So I replace these 2 capacitors by only one capacitor, that is C double dash. It is battery, C double dash, and here is C4. Clear? Okay. Now again, if you make charge to flow, see, charge is flowing. There is only one path. There is only one path. There is only one path. It means this C double dash and C4 they are in parallel. They are in series connection. These 2 capacitors are in same path. These 2 capacitors are in same path. Okay, means C double dash and C4 they are in series connection. And let their equivalent is C triple dash. Okay, so for series connection, 1 upon C triple dash is equal to 1 upon C double dash plus 1 upon C4. 1 upon C triple dash is equal to 1 upon 200 plus 1 upon 100. 1 upon C triple dash is equal to 300 by 20. 20000. If you simplify this, C triple dash is equal to 200 by 3 picofarad. Clear? Okay, these 2 capacitors are now replaced by only one capacitor with this battery. Okay, so it is first question, how to find equivalent capacitance. Again, another time, see, C2 and C3 they are in series connection, C dash and C1 they are in parallel connection, C double dash and C4 they are in series connection, C triple dash. Clear? First question over. Now you have to find charge and potential difference across each capacitors. You have to take reverse path. You have to take reverse path. How? See, C triple dash, you know its value. Connected with battery having voltage V is equal to 300 volt. From these 2 values C and V, what you will find? Q. To find charge on C triple dash. Q triple dash is equal to C triple dash into V. 200 by 3 into 3000. 300. So it is 20000, that is 20,000 microcoulomb. that is 20,000 microcoulomb. Clear? Simple. Okay, Q triple dash is equal to 20,000 microcoulomb. Now, see, you have to move on reverse path. Ask the question, what is C triple dash? What is C triple dash? What is C triple dash? Yes, here it is. C triple dash is series connection of C double dash and C4. C triple dash is series connection of C double dash and C4. In series connection, what is same? Charge. So I can write charge on C triple dash is equal to charge on C double dash is equal to charge on C4. Okay, so C triple dash is series connection of C double dash and C4. So charge on C triple dash is equal to charge on C double dash is equal to charge on C4. So you can write Q triple dash is equal to Q double dash is equal to Q4 is equal to 20,000 microcoulomb. Okay, now you know what is charge and you know capacitance. Then how to find potential difference? With the help of equation, V double dash is equal to Q double dash upon C double dash. 20,000 upon 200 is equal to 100 volt. What is charge? What is potential difference between two plates of fourth capacitor? V4 is equal to Q4 upon C4. 20,000 upon 100 is equal to 200 volt. See, in series connection we know that charge is same. See here. Charge on C triple dash is equal to charge on C double dash and charge on C4. But what about potential? Yes, we know that V is equal to V1 plus V2 for series connection. Apply here. Potential difference across C double dash is equal to potential difference across C double dash plus C4. Potential difference, again, potential difference across C triple dash is equal to potential difference across C double dash plus potential difference across C4. Across C triple dash it is 300. Now if you add this to 100 plus 200, it will be 300. Means from this you can verify your answer. Clear? Okay. Now it is only for fourth capacitor. We have to find another answers. So see, ask another question. V double dash, Q double dash. Okay, C double dash. In reverse. What is C double dash? C double dash is parallel connection of C dash and C1. C double dash is parallel connection of C dash and C1. In parallel connection, what is same? In parallel connection, what is same? Potential difference. So how to write? C double dash is parallel connection of C dash and C1. Therefore, potential difference across C double dash is equal to potential difference across C dash is equal to potential difference across C1. And V double dash is equal to V dash is equal to V1 is equal to 100 volt. Here it is V double dash 100 volt. Clear? Now you know what is potential difference and capacitance. So from this you can find what is charge. Q dash is equal to C dash V dash 100 into 100, 1000 microcoulomb. Q1 is equal to C1 V1 is equal to 100 into 100. It is 1000 microcoulomb. Clear? Okay. Again you can verify this answer. Total charge is 20,000. It is distributed equally 10,000 and 10,000. It is clear. Okay. Now again repeat part. C triple dash over C double dash over. Now C dash. What is C dash? C dash is series connection of C2 and C3. C dash is series connection of C2 and C3. And what is same in series connection? Charge. What is same in series connection? Charge. How to write? Charge on C dash is equal to charge on C2 is equal to charge on C3. Here it is. Charge on C dash is equal to charge on C2 is equal to charge on C3. So Q dash is equal to Q2 is equal to Q3 is equal to 10,000 microcoulomb. And if you know what is charge, capacitance is already given. You can easily find what is potential. That is V2 is equal to Q2 upon C2. 10,000 divided by 200 is 50 volt. V3 is equal to Q3 upon C3. It is also 50 volt. It is also 50 volt. Clear? Okay, if you apply series and parallel connection, you can verify your each and every answer. Yes, some is lengthy and yes, it is important question. It is one of the important question. Find capacitance and then take reverse path and find charge and potential. You have to remember just rules. In series connection, charges on each capacitor is same. For parallel connection, potential difference across each capacitor is same. Okay, then data will be given. You can easily find. One question is your homework and it is very easy question. Exercise 2.10. Capacitor having capacitance 12 picofarad is charged by battery having 50 volt. Then what is energy? U is equal to half C V square. One of the easiest question. Okay, U is equal to half C V square. Solve this question and send me answers. Pause your video and write down from board. Okay, it is one theory from old textbook, but we have to remember its result. Again, you will be not asked this theory in question paper in board exam. It is extra theory, but we have to remember its result. See, we know that two plates of capacitor charged by battery, free charge sigma f minus sigma f. If between them medium is air, electric field is E0. E0 is equal to sigma f upon epsilon 0. Now if you place any dielectric, polar or non-polar, okay, effect will be same. Then due to this external electric field, this dielectric is polarized, minus sigma b and plus sigma b, bound charges are induced. Okay, polarization P is equal to sigma b, we have already derived. Yes. Okay, what you have to remember, polarization P is proportional to E. You know this relation. So P is equal to epsilon 0 chi E. Okay. Polarization P is equal to epsilon 0 chi E. It is one relation that you have to remember. You also know what is resultant electric field in dielectric. E is equal to sigma f minus sigma b upon epsilon 0. So E is equal to sigma f. See, if you make sigma f is equal to E0 epsilon 0, E0 epsilon 0, minus sigma b is equal to this P, polarization, upon epsilon 0. If you take epsilon 0 this side, E epsilon 0 is equal to E0 epsilon 0, P is replaced by epsilon 0 chi E. Okay, now from this step how to write? Bring terms having electric field in dielectric together. E, it is E0, it is E. So take this term right this side. Okay, so E epsilon 0 plus epsilon chi E is equal to E0 epsilon 0. Now take E epsilon 0 common, then it is 1 plus chi E is equal to this equation. Now how to understand this equation? See, what is E0? Field in air. What is epsilon 0? Permittivity of air. Clear? Right hand side clear? E0, field in air. Epsilon 0, permittivity of air. What is E? Field in dielectric. E is field in dielectric. This side field is multiplied by permittivity, air. This side is field in dielectric. Then this term is called permittivity of dielectric. This term is called permittivity of dielectric. Epsilon is equal to epsilon 0, 1 plus chi E. Okay, and we know that epsilon upon epsilon is equal to 1 plus chi E, and it is relative permeability. Okay, it is relative permittivity. It is relative permittivity. So, relative permittivity of dielectric epsilon R is equal to 1 plus chi E. 1 plus chi E. Now again from this, E0 field in air, epsilon 0 permittivity of air, E field in dielectric, then this term is replaced by permittivity of medium, that is epsilon. Okay, so E epsilon is equal to E0 epsilon 0, make E a subject, it is E0 epsilon 0 upon epsilon. Now we know that, okay, epsilon upon epsilon 0 is equal to K, then epsilon 0 upon epsilon 1 upon K. Then E is equal to E0 by K. Now what you have to remember, see, if between two plates of capacitor, we have medium air, then electric field is E0. If air is replaced by another dielectric having dielectric constant K, then electric field in this region is E is equal to E0 by K. Electric field E is equal to E0 by K. And also, what is relation of potential difference? In this first case, potential difference between two plates V0 is equal to E0D. V0 is equal to E0D. Then in medium, V is equal to ED. V is equal to E0 upon K into D. It is about potential difference. Clear? So it is one extra theory. You have to remember this result. E is equal to E0 upon K. E is equal to E0 upon K, and also this table. because similar theory for magnetization, for magnetic field, we will study in chapter number 5. Clear? Pause your video and write down from bottom.